Today's lesson objective, students will prove triangles congruent by angle, side, angle, and angle, angle, side. So the first one we're going to talk about is angle, side, angle congruence, which is abbreviated ASA. The included side is the side between two angles. And so looking at the figures down here, I can see side AC is between angle A and C. So AC is the included side for angle A and angle C. Okay, and so if I have two triangles where they have an angle that's congruent, an included side, and another angle, then I know the triangles are congruent. And it's important that the congruent side is between the congruent angles. Okay, when the congruent side is between the congruent angles, then I know it's angle, side, angle. So here's my two angles, and here's the side between them. And so just like the side is between the angles, the S is between the two A's in angle, side, A, angle. So if I was using this in a proof, I would have to say that angle A was congruent to angle D. Side AC is congruent to side DF. And angle C is congruent to angle F. And if I have those three things in my proof, I can say triangle ABC is congruent to triangle DEF. In this case, by angle, side, angle. So looking at example 1, they ask if there's enough information to tell whether the triangles are congruent. So looking at the figure on the left, at first glance, it looks like I only have a congruent angle and a congruent side. But what you want to pay attention to is that there are also vertical angles. So I notice that these are vertical angles. And so we know that vertical angles are congruent. And so now I actually do have enough information. I know that those triangles are congruent by angle, side, angle. And if I look at the second figure, I see that angle STW is a right angle, and angle VWT is a right angle. And I know all right angles are congruent, so that means those are congruent angles. All right angles are congruent. So those two are. And then I also see that I have a shared side here. And anytime you have a shared side, it's congruent to itself. So I know that TW is congruent to itself by the reflexive property. And so for this one, I can also say the triangles are congruent by angle, side, angle. Angle, angle, side congruence is similar, but now the congruent side is not between the congruent angles. The congruent side is not between the congruent angles. And the S is not between the A's. So again, looking over here, I see I've got an angle that's congruent, another angle that's congruent, but the side that's congruent is not between angle A and angle C. So for this one, in a proof, I would say that angle A is congruent to angle D, angle C is congruent to angle F, and then BC is congruent to EF. So as long as I have all of that information in my proof, I can then say triangle ABC is congruent to triangle DEF, in this case by angle, angle, side. So what we've learned so far is to prove triangles congruent, we've got several ways we can do it. We can do it by the definition of congruent figures, by showing all the corresponding sides and all the corresponding angles are congruent. We can do it by side, 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 by side, angle, side, hypotenuse, leg, angle, side, angle, or angle, angle, side. Any one of those works to prove that triangles are congruent. But to reiterate what was said previously, there are no tow trucks, no angle, 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 and there are no donkeys, and can't have donkeys looking in the mirror either. So if you switch it around, it's still not okay. No narcissistic donkeys. And if you don't know what I mean by narcissistic, look it up. It comes from, I believe, a Greek story about one of the Greek gods, Narcissus. All right, so for another example, is there enough information to say the triangles are congruent? So if I look at the first figure, I have some congruent angles that aren't marked because I have vertical angles, but that's angle, angle, angle. We just said can't do that, so no, there's not enough information to say that those are congruent. And if I look at this next figure, again, look for those shared sides. We're sharing a side right here. And so I know that it's congruent to itself by the reflexive property. So we do have enough information on that one. And the side is not between the two congruent angles, so that one is congruent by angle, angle, side. And again, that was by the reflexive property there. Okay, so let's take a look at this figure and try and determine whether or not triangle STW, so we've got STW, we're going to determine whether or not that is congruent to triangle VWT. Whether they've given us enough information. Alright, so I see that I have a couple of right angles there. And I know all right angles are congruent, so angle STW would be congruent to angle VWT, because all right angles are congruent. And I also noticed that they gave me a couple of measures here for angle S and angle V. They both have a measure of 60 degrees, so angle S is congruent to angle V because the measures are equal. And then I see on the bottom here, they're sharing a side. Right where the yellow and blue mixed, it turned into green. So TW is congruent to WT by the reflexive property for congruence. And so now that I have all those parts, I have two angles and a non-included side. So triangle STW is congruent to triangle VWT by angle side. All right, so we're going to prove triangles are congruent using angle side angle, first of all. So we're given that AB is parallel to CD. I'll mark that. And AB is congruent to CD. I'm going to want to prove that triangle ABE is congruent to triangle DCE by angle side angle. So again, sometimes it helps if you extend out the parallel lines. And then let's mark a transversal. So looking at BC as a transversal, I can see that angle B is going to be congruent to angle C because they're alternate interior angles. And I want to use angle side angle, so I need to show also that angle A is congruent to angle D. And if I mark another transversal here, this could also be a transversal, and I have a new set of alternate interior angles. And so A is also congruent to D. And so if I can show all those things, then I have enough information to say the triangles are congruent by angle side angle. So my first step is already written down here. All right, and then we said that we knew that angle B is congruent to angle C, and angle A is congruent to angle D, and both of those are by the alternate interior angle theorem. And I see that they already gave me the set of congruent sides here. So there's my sides, here's an angle, here's another angle. I have enough information now to say that the triangles are congruent. So I know triangle ABE is congruent to triangle DCE, and it's by angle side angle because the congruent side is between the two congruent angles. Now we're going to take a look at the same proof, but this time we're going to do it by angle side. So it's the same information we were given before, and this time we're going to use a different theorem. So like we said, we had some congruent angles because of parallel lines, and they gave me, those were parallel and congruent. And so I know that angle A is congruent to angle D by the alternate interior angle theorem. This time I want to use angle side though, so I don't want to say that B and C are congruent. Instead, this time I'm going to use my vertical angles here. Now I can't call that angle E. That's too ambiguous. I don't know which angle you're talking about if you say angle E. So remember that when you have that kind of a situation, you have to use 3 letters to talk about the angle. So angle AEB is congruent to angle DEC. And I know that because vertical angles are congruent. So now if I look at it, they gave me a side here, I have an angle here, and I have my other angle here. And so I have enough information to say that triangle ABE is congruent to triangle DCE, and in this case, it's angle, angle, side. That concludes this video. Thank you.